Voyager 1 lifted off from Cape Canaveral atop Titan Centaur rockets.
Launched with modest expectations and technology that already felt fragile, Voyager 1 has outlived every prediction, drifting into realms no mission was designed to endure.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Yet, at the fading edge of the sun's influence, it encountered a quiet, continuous tremor in the darkness. A cosmic hum that challenged our models and revealed how incomplete our understanding still is. The journey that should have ended. Voyager 1's story began as a calculated gamble wrapped in aluminum and hopeful engineering, a spacecraft built for a mission so brief that no one expected it to carry relevance beyond a single generation. Its circuitry reflected the limits of the 1970s, and its design echoed the humility of a team who anticipated constant failure, yet prepared meticulously for resilience. Engineers knew that once the spacecraft left Earth's protective reach, no repair crew would ever touch it again. So they built redundancy into every layer, duplicated components, fallback pathways, and instruments that could survive long periods of dormancy if the mission demanded sacrifice. These measures were not acts of optimism, but careful acknowledgments of the hostile environment awaiting the spacecraft. As Voyager pushed deeper into the outer solar system, its endurance became an unforeseen resource, carrying it far beyond its intended timeline, while the world that launched it transformed dramatically. Generations of scientists retired, new technologies replaced old paradigms, and entire fields of inquiry shifted. Yet the spacecraft's faint signals continued slipping through the void. Every transmission that reached Earth acted as both a scientific data set and a quiet testament to engineering foresight. This improbable survival established the foundation for discoveries no blueprint had imagined. If Voyager had followed its expected lifespan and fallen silent decades earlier, the boundary it would eventually encounter and the subtle signals it would detect would have remained hidden, leaving humanity blind to an entire frontier of the solar system's architecture. The outer planets that rewrote the rules. Voyager 1's expanding journey soon demonstrated how limited our early assumptions about the outer solar system truly were, because each planetary encounter fractured another layer of certainty and replaced it with something far more dynamic. Jupiter, once imagined as a world encircled by quiet moons, displayed volcanic eruptions on Io, so powerful that they reshaped the surface in real time, revealing a level of internal heat driven by tidal forces that no prevailing model had predicted. Europa, with its bright fractured shell, offered evidence of a concealed ocean beneath its ice, shifting the conversation about potential habitability in regions previously dismissed as too cold and inert to sustain complexity. Saturn transformed from a distant ringed icon into a system of intricate structures, where shepherd moons sculpted patterns with gravitational precision and spoke-like features drifted across the rings in ways that defied simple classification. Uranus presented a magnetic field oddly tilted and displaced from the planet's core, challenging theories about planetary formation and internal layering. Neptune displayed furious winds that surpassed any recorded on Earth, and storms so large that they suggested atmospheric engines operating on scales far beyond earlier expectations. Each revelation forced scientists to adjust not only their understanding of individual worlds, but also the processes that shaped the solar system itself. Voyager's observations demonstrated that presumed stability often concealed hidden layers of energy, fluid movement, and unpredictable interactions. The more the spacecraft uncovered, the clearer it became that the universe rarely conforms to the boundaries humans try to impose upon it. This steady unraveling of assumptions prepared the scientific community for the possibility that the outermost frontier would not offer simplicity or closure, but another set of mysteries waiting to confront long-held models as Voyager approached the edge of the sun's influence, crossing the boundary no one could see. As Voyager 1 drifted farther from the familiar planets, scientists anticipated a gradual thinning of the solar wind and a subtle transition into the region where the sun's authority faded. Instead, The spacecraft entered a turbulent zone where charged particles compressed, slowed, and collided with opposing forces from interstellar space. This region, later defined as the heliosheath, behaved less like a clean border and more like a restless frontier, shaped by shifting pressures and chaotic magnetic interactions. Voyager's instruments recorded fluctuations that suggested a complex interplay between solar particles and the surrounding galactic medium, revealing an environment far more intricate than any boundary drawn in early textbooks. When Voyager finally crossed the heliopause in 2012, the moment offered no dramatic marker. Rather than an abrupt shift, the spacecraft detected a sudden drop in solar particles, while simultaneously measuring a rise in cosmic rays migrating from the wider galaxy. This combination confirmed that it had moved into interstellar space, a realm governed not by the sun, but by forces operating across immense distances. Yet the true surprise emerged only after the crossing, when the spacecraft began to detect a persistent and unexpected vibration embedded within the interstellar plasma. This steady signal, often described as a cosmic hum, arrived as a subtle oscillation in plasma waves that maintained a remarkably stable frequency over time. Prior models had assumed interstellar space to be quiet and nearly empty, yet Voyager recorded a continuous resonance that suggested density, structure, and activity where silence had been presumed. The presence of this hum revealed that interstellar space was not a void, but a medium shaped by long, slow waves and unseen interactions. With this discovery, Voyager demonstrated that even the threshold between star systems contains complexities that challenge humanity's understanding of what lies beyond the sun's reach. What the cosmic hum really means. The discovery of the cosmic hum transformed Voyager 1 from a distant traveler into an active listener, positioned within a medium that scientists had long considered sparse and uneventful. Instead of drifting through an almost perfect vacuum, the spacecraft revealed a region shaped by slow, persistent plasma waves, whose steady rhythm reflected the density and temperature of the interstellar environment. This discovery allowed researchers to measure variations in that density with a precision no previous mission had achieved, offering a new way to map the structure surrounding the solar system. The consistency of the signal suggested that the interstellar medium possessed far more stability than expected, challenging the assumption that such vast regions behaved chaotically on small scales. Because Voyager's instruments were never designed with this type of detection in mind, the fact that they registered such subtle oscillations highlighted both the robustness of the hardware and the ingenuity of the engineers who prioritized longevity over complexity. Their decisions enabled the spacecraft to extend its mission into realms no designer could fully anticipate, essentially turning Voyager into an observatory for dynamics that operate across galactic distances. Understanding the hum also reframed the transition into interstellar space as an encounter with an active environment rather than a symbolic milestone. Instead of marking a point where the influence of the sun ceased, the region became a laboratory, revealing how stellar systems interact with the wider galaxy. This insight underscored the idea that the solar system does not sit in isolation, but moves through a textured medium shaped by forces older and larger than the sun itself, the machines carrying humanity's memory. Long before Voyager 1 detected the steady tremor of interstellar plasma, it carried another mission layered quietly beneath its scientific goals: the preservation of a moment in human history. The Golden Record, curated by a team led by Carl Sagan, transformed the spacecraft into a messenger bearing music, images, greetings, and mathematical signatures meant to represent the diversity of life on Earth. While it remains uncertain whether any distant intelligence will ever encounter it, the record reflects a decision grounded not in expectation, but in aspiration, acknowledging that exploration is as much an expression of identity as it is a pursuit of knowledge. Voyager's endurance deepened the meaning of this gesture. As the spacecraft drifted farther from the sun and its systems aged, every surviving instrument reinforced the idea that human creations can persist in environments that outlast the societies that built them. Its continuing ability to sense the structure of interstellar space connected the scientific and symbolic dimensions of the mission, revealing a spacecraft simultaneously gathering data and carrying a time capsule of its origin world. This dual role allowed Voyager to act as both observer and ambassador, bridging empirical discovery with the emotional resonance of a civilization choosing to leave a trace of itself in the cosmos. The detection of the cosmic hum added a further layer to this narrative by exposing a universe that remained active even in its quietest regions. Voyager thus became a participant in a dialogue between humanity and the galaxy, interpreting the faint rhythms of interstellar space while transporting evidence of the world that once guided its launch. What Voyager teaches us. Voyager 1's continued presence in interstellar space invites reflection on how human creations intersect with cosmic timescales. Because the spacecraft embodies a rare overlap between technological lifespan and the slow evolution of the galaxy itself, its ability to sense the subtle structure of the interstellar medium demonstrates that even aging instruments can reveal patterns that reshape scientific understanding, especially when designed with enough foresight to endure environments their creators could scarcely imagine. The steady plasma hum it recorded illustrates that regions once dismissed as empty actually contain rhythms shaped by forces extending far beyond the sun's reach. This realization reframes the solar system as a participant in a larger galactic environment rather than an isolated family of planets, thereby challenging long-standing assumptions about humanity's position in the universe. Voyager's journey reminds us that perspective does not come from distance alone, but from the patience required to listen to signals that unfold across decades. The spacecraft's endurance encourages a deeper appreciation for the fragility of Earth and the resilience of curiosity, linking scientific discovery with a broader understanding of how small our certainties remain. Voyager 1 drifts onward with a diminishing voice, yet an expanding legacy, carrying the pulse of a distant world and the quiet rhythm of the galaxy around it. If its journey moves you, stay curious, explore boldly, and join the effort to understand the universe that shapes us all.